Hello everyone, my name is Roy Carter and I'm here today to present to you the second to last teacher training for the geoscience portion of your C-STEM challenge. And so now let's jump into it. And so the first thing that I want to present to everybody is just kind of like, let's talk about where everybody should be at in the entire process. Now we've begun with the first step in this entire process was to introduce you to the challenge, and then the then the then after that you were supposed to go through and research and then start designing solutions. And then now everybody should be at the point where their solution should be created, and then they should be start to at least design prototypes and then start constructing those prototypes. And then last but not least, after the construction, then what we'll talk about next week is all about how to create an artifact or what you will be actually turning in when you come for the CSIM challenge. But for right now, everybody should be at the prototype and the construction of the prototype. So just to refresh everybody's memory, the Geoscience Challenge states, for the CSTEM challenge this year, states that an exponentially growing population has resulted in rising demand for resources despite our limited clean water and energy supply. This has led to a global shortage in clean water and natural resources. In order to fulfill the demands and maintain the quality of life for the human race, there is a need to design smart and efficient ways to preserve and utilize our resources. Students will invent a technology or mechanism from recycled and reused materials and 3D printing technology that serve as a solution to clean water and energy shortages. The 3D printed object to be integrated into the invention must be a geometric shape and not exceed 3 inches by 3 inches by 3 inches. Now, what will we be looking for when you actually come here in April? Well, so the requirements is that all the geoscience project submissions, they have to be accompanied by a scaled engineering design on graph paper, 11 by 17 inches. And so what we're looking for, what we're saying is that there doesn't need to be a dimension requirement for the overall invention, but we need to have two team members from each school level. They must be able to collaborate and present, give a 5-minute oral presentation using Prezi to explain their geoscience challenge solutions. Now, as we discussed at the last teacher training, one of the things, there's probably been a lot of questions around how do I actually go about creating the solution. And one of the things that I want to emphasize to everybody out there is that, first of all, there is no correct answer. What I would like for everybody to be is be bold, be creative, and don't be afraid to try something new. And so and then another thing that um, I would suggest people doing is looking back at some of the previous teacher trainings. We discussed a number of different avenues of investigation for consideration, such as potable water or desalination. So can the technology or mechanism access sources of clean water and energy? Or another thing we talked about was about oil and gas, or the whole called fracking or hydraulic fracturing. And so can the technology effectively recycle or reuse clean water and or energy resources? And last but not least, maybe the technology or mechanism can reduce the amount of waste needed for energy production, such as the 3D printing of a micro solar panel. Now, for everybody that's in the process of constructing and designing their prototype, there's a number of ways to go about it, but this is the way I would suggest. First off, make a conceptual sketch of the prototype. And so feel free to use as much sketch paper and make sure to use pencil and not pen when you're doing your sketches. And so what you want to do is sketch that prototype from multiple viewpoints. And when I say that, I'm saying you sketch the prototype from where, as you're looking at it, from the side and also from the back. So therefore you get an understanding of what the prototype looks like and how it's going to fit into your overall solution. And so also try to complete a more detailed drawing using graph paper. Okay, try to make a model of the invention out of foam or paper. So therefore, after you create your detailed drawing, try to make a little life size or a little model out of just basically take a block of foam or some paper and try to create that model and see what it looks like. And then as you do that, that'll give you a sense of what it looks like and if you need to make any adjustments. And as you need to make adjustments, feel free to redo the prototype as many times as possible until you get a prototype that meets your needs, that's satisfactory to you. And then, as the old saying goes, if at first you don't succeed, always try again. There's never it's pretty much going to be pretty assured that the first prototype you make will not be the one that you use. And so always feel free to try as many times as possible until you get the prototype that you really like. And so once that prototype is finished, then be sure to make sure to complete the assignment and put the drawing on 11-inch by 17-inch graph paper. Now we talk a lot about 3D printing, and so one of the things I want to do is just briefly touch upon what is 3D printing. And so 3D printing, it's a very interesting, very fascinating new manufacturing process. And so what it does is it produces three-dimensional solid objects from digital models. And then you also hear 3D printing also called additive manufacturing. Because what you're doing is you're actually adding layers of material on versus typical manufacturing process is subtractive. So you basically start with a big block of, let's say, wood or metal, and then you remove the material, or you're subtracting from the original material through processes such as cutting or drilling. And so additive manufacturing, actually, you can do a lot more intricate shapes, very intricate, very complex shapes, as you can see from that picture that I have up there of a 3D printed plastic objects. And so that's one of the very exciting things about 3D printing. And also, it allows for rapid prototype creation and rapid manufacturing of parts. And then another advantage of 3D printing is that it allows for mass customization of parts. And then probably the biggest advantage of 3D printing is that it potentially can eliminate very expensive supply chain issues by allowing companies to produce parts on demand. So for example, NASA is investigating 3D printing instead of having, because as you can think of, take for example the shuttle. The shuttle, when it flies up to space, it typically carries a number of different parts. And so the parts carry weight. So what instead of if the shuttle, instead of carrying all these different parts, it could carry a 3D printer, and then it would print or produce the parts as needed. And so that's one of the many multiple potential avenues or advantages of 3D printing. And I would highly suggest if people are interested in the whole concept, there's a number of great resources out there. And I highly recommend looking at, because right now they're doing some very fascinating stuff with 3D printing. They're actually using 3D printing to produce human organs such as ears and lungs and kidneys. And so I highly recommend that people want to get some more information about 3D printing to take a look at it. So one of the things that, so this is really, we're not going to, excuse me, we're not going to be too long in the presentation today, because one of the things that I'm curious about knowing is that I want to understand where everybody is in the process. So as I said before, everybody should have, the first step in the process was to research and understand the problem. And then the middle step was to propose potential solutions and begin the design process. And then the testing of ideas and construction of prototypes. So one of the things that I request everybody to do is that if you need some help, feel free to contact myself or the system staff if needed. And then also one of the things that I'm curious about is that where is everybody in the process? And so one of the things I would ask is that people just shoot me a quick email. And so I'm going to put my contact information up here, roycarter@chevron.com. And so if you, so one of the things that I would like for everybody to do is just shoot me an email, tell me where you're at in the process. And so that would let me know exactly where to help you, because the next teacher training, we only have one more teacher training left. And so I want to make sure that the next teacher training makes sure that fits the majority of the people's needs out there. So in order for me to do that, I need people to help me out here. And so shoot me an email, tell me where you're at in the entire process. In terms of, even if you haven't started, please just still shoot me an email and let me know. And so therefore I can tailor the next session to meet your needs. Now with that said, we have some additional resources that I will flip through. And so these resources are available to anybody. And so these are free resources out there. And so if you need some additional help, feel free to grab this presentation, and then those can take you to additional information. Okay, so therefore, I'm done with this presentation for now, but as I said before, please contact me if you need any help, and hope everybody's having a good day. Take care. Bye-bye.